Hello everyone, we are Team68 and today we would like to share our project for COMP90024 Big Data Analytics on the Cloud. Our project focuses on analyzing social media sentiment related to Australian federal election. We collected data from Mastodon and deployed the entire system on the Lecta Research Cloud, using Kubernetes, Fission, and Elasticsearch. The main goal of our project is to explore meaningful public opinion terms. We track sentiment over time and focus on key terms and found the causes behind the sudden changes in the political. To support our analysis, we built a cloud-based system. On the left is our local environment, used for deployment, system monitoring, and data analysis. To connect to the cloud, we go through a bastion node. It acts as a secure gateway. We use SSH tunnel and port forward to access the cloud cluster. We use the OpenStack RC file, which gives each team member secure access to the Lecta Research Cloud in the Melbourne zone. At the center, we have a Kubernetes cluster. There are 4 nodes in the cluster. One is master node, and the other 3 are workload. Each node assigned by 2 base CPUs and a light GB RAM. Inside the cluster, we have 3 main services: Kubernetes for showing data dashboards, Elasticsearch for storing data, and Fission for running our harvest function. Finally, on the right, our Jupyter Notebook connected to the cloud via REST APIs enable us to run sentiment analysis and show visual results in real time.
Hi, I'm Renzo. Here's an illustration of our system. Here we use a script to create configs. And we can see here that the config maps have been created. And here's the script that we delete all the resources on the server. And we see it. And now we create the specifications. We apply the changes to the server. This is a function list. And this is an illustration of how our pre-commit checking works. We change the code. And we try to commit it again. And here we test the setup indices function. And we can see that the comments. Here's a test for fetch Mastodon.
The natural language processing of the data in the Elastic database is run through a Python program in the backend. Its main component is a loop. The loop performs Elasticsearch query, assigns sentiment score to post, and then writes back to the Elasticsearch. When queried from Elasticsearch, the unprocessed posts should not contain the sentiment score attribute, and their content contains one or more keywords. Given that the query speed is much faster than the processing speed, every time we query the whole database, but only process limited entries. For natural language processing, we use the tool VEDA. It's a sentiment analysis tool that's suitable to microblog-like contexts. VEDA has fast computing speed, allowing programs that handle large amounts of data to run efficiently. After getting the sentiment score of one post, we add the sentiment score attribute to it. Having processed all the posts extracted by the loop, the update information will be written back to database. The bulk function is used to write back the whole batch of posts to Elasticsearch, which is efficient and avoids the high latency of updating data one by one. After executing the loop and add the sentiment score attributes to the election-related posts, the aggregation query function of Elasticsearch is called for statistic and visualization.
We designed 3 scenarios of Australian federal election during 2025 through social media data. The first one is overall line graphs of public attitudes towards two parties. The 2 lines in the chart shows the changes of average sentiment scores over time for keywords of Albanese, Dutton and their related parties. We assumed the fluctuation in public attitude towards Dutton as one of the reasons that he was less elected. The second scenario is overall word cloud plot of the two parties in the election. In Albanese's word cloud, Walker appears frequently since the Labour Party is founded on representing the interests of workers and advocating for labour's rights. And in Dutton's picture, the word economic appears many times since he emphasized his economic opinions, thereby driving users' discuss on related topics across social media. Both of the word cloud plots present the appearance of Trump. Although Trump is not directly connected to the two Australian candidates, international diplomacy and trade relations may have led users discuss his name. Furthermore, Dutton's opinions performed similarly to Trump's, so Trump appears more on his graph than Albanese. The third scenario is reasons analysis through word cloud plot of special time shown in line graph. We take April 29th for Albanese and April 21st for Dutton for examples. From the first picture, we can see an apparent word economic. Just a few days before end of election, poor economic data or policies could lead to a drop in confidence in Labour Party. We assumed it may also due to the pressure from Dutton's policies on the economy. In the second graph, the word cloud with want and need shows that Dutton's policy at this time may not meet the actual needs of the public, leading to decrease of support. Also, the word women means that many women electors may feel gender unfairness from Labour Party, leading to drop of scores.
In our project, we focused on reusability and automation, especially through modular YAML templates and GitLab CI/CD integration. We reused the same YAML structure across multiple function functions like fetch, insert, and update. So adding new pipelines only required minimal config changes. This modularity improves maintainability and makes the system easier to scale. To make sure each module works correctly, we followed a test-driven development approach. We wrote unit tests for all key components, like fetch new posts, create doc for posts, and insert new docs using PyTest. The test suite checks document transformation, boundary handling, API fallback logic, and all transformation at the function entry point. All tests are automated and triggered in our GitLab CI pipeline whenever someone pushes new code. You can see the test summary and results in the report. And here's a snapshot of the pipeline run. To sum up, our project delivers a scalable, cloud-based sentiment analysis pipeline. It continuously processes social media data and provides real-time insights into public opinion. With modular YAML templates and automated testing via GitLab CI/CD, we have built a system that's not only reliable but also easy to extend. Thanks for listening.